So let's look at a worked example in which we take of implementing an IPv6 address plan. And we're going to continue with the exercise that we did during the webinar. And the exercise is simply this. An ISP has operations in 10 cities. The largest of these cities has 50 POPs or 50 sites. And the largest of these 50 sites has 2,700 clients. How much space should it request from Alphanet if it plans to give each of its customers a /48? Like I mentioned during the webinar, the first thing we want to do is, model this network as some kind of a hierarchy. And so it's obvious, you can see here that the hierarchy here is, first thing is you've got cities, and within the city you've got POPs, and at the POPs you've got clients. So we've got something like that. Level 1 of the hierarchy is cities, of which there are 10. Level 2, sites, of which there are 50 in the largest city. And level 3, you've got 2,700 clients per site. And this is /48, the end network size. So we are saying that each of these 2,700 clients, we plan to give them a /48. That is a design decision. It's not something that we calculate. Now here comes the calculation. How many bits do we need for each of these levels? For the cities, for the 50 cities, so for the 10 cities, for the 50 sites in each city, for the 2,700 clients at each site. So for the 10 cities, we just come down to this lookup table and look for the closest integer that is equal to just greater than 10, and that is 16. So we need 4 bits to represent 10 cities. Similarly, for 50 sites per city, if you look down to the table, the closest integer equal to or greater than is 256. That gives us 8 bits to reserve for sites within each city. And finally, for the 2,700 clients at each site, if we come down to the lookup table, we see that the closest thing is 4,096, and that's 12 bits. Therefore, the amount of space that we need from Alphanet is this /48, that's the end network prefix size, minus 12 minus 8 minus 4, which is a /24. Okay. The /24 is the amount of space that you need to get from Alphanet in order to design a network that's specified in the problem. Now let's imagine that we go to Alphanet and we make a request in the host masters. They give us a block of /24s. So this is a specific block, 2001 0D00/24. As you can see, the parts in right are exactly equivalent to 24 bits because each of these characters, these hexes as I call them, are 4 digits. So this is 16, this is 20, this is 24. The rest, that's the part that the subnets are going to occupy. So implementing an address plan simply means taking this /24 and breaking it down to match it to our hierarchy and our network topology. So let's see how it aligns to the hierarchy. So this is the hierarchy. We've decided that we want to give a /48 to each of the customers. In order to do that, each site must have enough space so that 2,700 potential clients have a /48. And the amount of space required per site is a /36. /36 we get that simply by subtracting 12 bits here from 48. Similarly, each city must have enough address space so that the 50 sites or more sites within it would have a /36. And we get the amount of space by subtracting 8 bits from 32. And that's how we get for the city a /28. And of course, finally, the entire network must support the ability to give a /28 to at least 10 cities. and we get the amount of required space by 28 minus 4, which is /24, which we calculated. Now, what we're going to do next is we're going to go into an IP address management system, PHPIPAM in this case, and we also use a Google spreadsheet to actually implement this address plan. So we're going to start. So this is the IP address management system we call PHPIPAM. I'm using the online demo, which you have access to as well. If you just go to the website demo.phpipam.net, you can sign up and actually use it as a playground to actually implement your own IPv6 address plan. So, continuing with our example, we have been allocated the space 2001 0D00/24 from Iphonic. So let's go ahead and add it here. So I put 2001 db, no, not db, 0D00 : /24. And I'm going to call it Sahel allocation. I click on add. We've got the /24 Sahel allocation. So this is what we're trying to do, is to break that /24, first of all, level 1, that's city level, to /28. So this is what I'm going to do. I'm going to scroll down, look at the actions, edit subnet properties. I'm going to scroll down to resize and split. So I'm going to say split the subnet into /28. And I'm going to call them Sahel city level, city number 1, 2, 3, 4. Then I go ahead and click split subnet. Split successful. And so you can see here, that's my /24, split neatly to several /28. Now, the next thing I want to do is I'll take the /28 and allocate them to each city, and then for the level of each city, I want to split them into several /36s. But first of all, before I do that, it is usually good practice to reserve the very first one, the very first block in the range for your infrastructure. So I'm going to go in here and rename that my infrastructure. So I'm not going to touch that. And remember what we said, try not to give things back to back when you're allocating, subnets to different entities. Do not do back to back. So rather than pick one, I am going to skip to 1, 2, 3. So it says 10 cities. And I have here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I'm going to start with this one. So I'm always going to skip one. So I'm going to pick this city number 1. And again, that's what I want to split into several /36s. So I scroll down, of course, edit properties, city number 3, yes. Let me just call this specific city. It says I happen to find right now I'm in Dar es Salaam. I'll call it Dar es Salaam. And so I want to split this into several /36s. So you can see here, it's going to give me, if I split this /28 into several /36s, it's going to give me specifically 256 /36 subnets. And I want to call them DAR. Remember we said between the cities we've got sites, so I'm going to call it DAR site 1 or DAR pop 1. Site number is going to be 0, 1, 2, 3, 4, etc. So I can go ahead and split. Split is successful. And so we can come in here and see it exactly. So you've got, you see, DAR /28 split into several /36s. And so continuing down each prefix. So these are what we're going to allocate to each site. And again, I always want to give, we said there are about 50 such sites. Remember the problem said there are about 50 such sites per city. Now, what I want to do is take each of these sites and split it so that I can have into the customer networks, which are the /48s. So again, I always want to reserve that first block for something that's special in the future, and I can come down to the fourth one. I could start with the second one, but I always like to leave a difference. So in multiples of ideally in multiples of 4. But if you realize that using multiples of 4, you're going to exhaust your range, then you go with multiples of 2. So in this case, I'm going to start with the 256 /36s, and the largest of which right now is 50 cities. So I'm going to play safe and go with multiples of 2. So I'm going to start from here. This is my customer. For this site, I'm going to break into customer networks. So, the drill. Come into DAR site 3. That's it. And I want to split it into customer networks. And the customer networks need to be, as you can see here, /48s. So I'm splitting /36s into /48s. So I come over here to split /48. As you can see, okay, I don't see /48. This software does not support the ability to split that large. So what I'm going to do is that I'm going to split into several /44s first, and then take a each /44, then split into /48s. That makes things much more manageable. So I'm going to call it DAR site 3 customer 48 block. Customer 48. Block 48. Dash something. I split this up, and so you can see here we've got /36 splitting several /44s. Now I'm going to take one of these and split it into my /48 for customers. So I click this one here, but I'll start with this first one. I go and split it into /48s. So I can have 16 /48s. So each of those blocks is going to take 16 customers. So 16/48. And of course, this is what is going to be allocated to each of my customers. Now, so what we did here, because of the inability to split, we split the /36 into /44, and then went from there into /48. And in doing so, we're sticking to nibble boundaries, which is generally good practice. However, we could also have gone from a /36 to a /40 so that we have fewer blocks that can contain more customers. So let's do that with the next block of addresses. So I'm going to take this, we had 2000, so I'm going to skip and use this one. So I'm going to split it into from /36s into /40s, 16/40s. Site 5, I'm going to call this block of 40. Then 1, 2, 3. I've got fewer, literally 16 of them. So I can start this one and break into several /48. And if I go break it into several /48, what do I have? Split this into /48, 256. So each of those blocks is going to take 256. Then I say this is customer number something. When the moment comes to provision to your customers, you just come in here and this is what you're allocating to customers, and you can export this into a CSV, into a spreadsheet, which can go into your radios or whatever. So this becomes living documentation. Now, one of the things I would like to demonstrate is what we do with the infrastructure addresses. Remember we said we always want to keep this for infrastructure addresses, and the first thing I want to do from here is allocate 1/16 for all my loopback addresses across my entire network. And so I can add a nested subnet of size /64. I said this is Sahel loopbacks. Master subnet, we leave it there. So successfully added, and if you go, you can see it here. So we do this because just imagine if you try to subnet all of the /28 into /64s. First of all, it's not possible with the software, but then even if it were possible, we'll have a long list here. We don't really care about that. Now, the other thing I can do is I can choose to add under this is /48 for all my point-to-point links. That is for point-to-point links. And again, now what I do is I say add a /48 for point-to-point links. Let's pick this first available one. Point-to-point links. Call that Sahel. Sahel is the name of our make-believe ISP. It's not some make-believe. And click add. And there you go. So every time I have point-to-point addresses to give, I can do that from here. I can now further subnet this into several /64s so that each point-to-point has its own /64. The reason we want to do this is because now we have a single prefix that we can write access lists to protect so that they're not reachable from anywhere else except from maybe management stations. So I can simply add some prefix So I need to add a /64. This is this available /64. I'm just going to call it P2P number 1. Of course, later on when you actually allocate it to apply to your network infrastructure, you give a more restricted name. For example, point-to-point link to upstream, point-to-point link to data center, all of that. I click add. So you see it right there. Of course, you can add more. Okay, with P2P point-to-point number 2. And so you could do that. So you can add as many point-to-point links as you want. The beauty of this is that you don't know, so long as you're doing it here, you can have one access list that protects all current and future infrastructure links. And when you have an infrastructure link, you just put it there. So you can see here, this is actually an implemented IPv6 address plan. So obviously you want to do this, repeat for each city, you subnet into various slash. Okay, so you've got your allocation from Affinity /24, which you've allocated broken down to level of cities. You've reserved this for infrastructure, from where you've put a block aside for loopbacks, and then another /48 for point-to-point links. And you've come to the first city, which you broke into several /36s for the sites, and then you went for each site, you broke them into /44s, which were further broken into /48. So this is what you'll be giving customers. If you wanted to, in this case, this site, for example, we broke them into blocks, /44 blocks, which essentially take 16 clients. But if you wanted fewer blocks that take more clients, that's the example we did here, where we broke our /36 into /40s, specifically 16 of them, and each of these, 256 of them, and each of these, we broke our /36 into 16 /40s, and each of these /40s could take 256 clients. So whatever you choose to do is really up to you, but the most important thing to do is to say, use an IPv6 address management system. And that is it.